Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In the previous lecture, we discussed about random variable and probability density function and probability mass function for a univariate data where only one variable has been provided to us, which we considered as x. In today's lecture, we'll move forward to probability density function and probability mass function for a bivariate data. Means we have two variables x and y. So probability density function and probability mass function will denoted by PDF and PMF. So in bivariate data, probability density function can be represented as the function of two variables x and y, and it can be written as integration. Suppose there are two variables x and y. X goes from minus infinity to infinity and y also goes from minus infinity to infinity. Then probability density function, joint probability density function of x and y will be minus infinity to infinity, minus infinity to infinity, f of x and y, both the functions into dy into dx. And this must be equal to 1 as stated by our laws. So this is PDF of a bivariate data where two variables are present, x and y, and this is known as joint density function. Okay, so this is our joint PDF of joint density function. Now if we talk about PMF, which is probability mass function for discrete random variables, where we have been provided two variables again, x and y. Then the PMF of two variables x and y, where x has the values 0, 1, 2 up till so on till n, and y also has value. Suppose this is n1 and y also has value 1, 2, 3 up till n2. So this will be the PMF of the joint PMF of these will be summation, double summation. First summation is over x from 1 to n1, and second summation from is of y from 1 to n2, which and pxy, and this must be equal to 1 according to our law, and this is known as joint mass function of two variables. These are very small topics, and we are taking every smaller topic so that you can understand the exam point of view better. And let us move forward with another topic, which is marginal density. Marginal density and marginal mass function. Marginal density function. If we talk about marginal density function, then marginal means from 2 we just want to know about 1. So density, from density function, it is for continuous random variable. Suppose we have to find the marginal density function of fx, then the function will be integration and the limits of y will be there, joint PDF of fxy dy. This will be our marginal density function for x. And if we have to calculate marginal density function of y, then it will be integration with the limits of x, fxy dx. You just have to know, if you have to calculate for x, then uh, the limits, and with respect to difference integration will be of y. And if you have to calculate for y, then the integration, the limit integration, and with respect to the integration will be of x. Similarly, marginal mass function. This is for discrete data. If we have to find the marginal mass function of x, which is pxs, which will be nothing but summation over y, pxy. And if we have to find the marginal mass function of py of y, then it will be summation over x and joint mass function of x and y. These are very simple formulas, and I hope you all know it beforehand only. This is just a revision. So let us move forward to calculate questions on them. This has been given to us. The question says that there is a bivariate function. Let us keep it aside. There is a bivariate function, and the joint density function have been provided by kxy, and here you can see that it is probability mass function because x and y are taking discrete values. So they have asked us to find that what should be the value of k, so that this is joint probability mass function. Now we all know that summation over x and summation over y, p x y, should be equal to 1. Here summation over, we can write summation goes from x goes from 1 to 3, summation of y goes from 1 to 3, pxy is k xy equals to 1. Now k will come outside because it is only in multiplication, and here the multiplier will be x 1 2 3 and y 1 2 3, and they are on multiplication. So if x is multiplied, x has value 1, so it will get multiplied. This works like this: x has value 1 2 3 and y has value 1 2 and 3. So x and y will get multiplied. What will be the value? 1 into 1, 1 into 2, 1 into 3, 2 into 1, 2 into 2, 2 into 3, 3 into 1, 3 into 2, 3 into 3. All of that should be considered. So I'm just writing the answer. 1 into 1 will be 1, 1 into 2 will be 2, 1 into 3 will be 3. Because this is a summation, so we are adding. 2 into 1 will be 2, 2 into 2 will be 4, 2 into 3 will be 6, 3 into 1 will be 3, 3 2s are 6, 3 3s are 9, which should be equal to 1. Now here, if we add them, this is 10, this is 20, and all of them added will give us 36. So it will be 36k equals to 1, and k has our final value, which is 1 upon 36. And in the question, the option is B, 1 upon 36. If k has the value 1 upon 36, then only this function, bivariate function, is considered as joint probability mass function. Now moving forward to the next question. Here we have been provided with joint probability density function, and we have to find the probability x is less than or equal to y by 2. Now they have given us this limit as well. So since this is they are saying that it is a joint probability mass function, and we have to find the probability of x is less than y by 2, means we have to find the probability of this equation. Then it will be double integration. First integration will be x will be of x is greater than 0 and x is less than y, but here they have given we have to find x is less than y by 2, so we'll put the limit y by 2, and y has the limit from 0 to infinity, so we'll put that 0 to infinity. Fxy is 2 into e raised to the power minus x into e raised to the power minus y dx, because first integration is of x and the next one is dy should be equal to 1. Now if we keep outside all the values of y, then it will be 0 to infinity. 2 will come outside because it isn't considered under integration. E raised to the power minus y, integration from 0 to y by 2, e raised to the power minus y minus x dx, and then dy, and we don't have to find it, so we can cut this out. We have to just solve this one. So if we integrate e raised to the power x, we'll get our answer as e raised to the power x minus x upon minus 1, and putting the limit 0 and y by 2, we'll get it as 1 minus e raised to the power minus y by 2. You can put it and keep it and see yourself. So it will be 2 into integration 0 to infinity e raised to the power minus y 1 minus e raised to the power minus y by 2. And here, if we multiply e raised to the power y inside, then we'll be getting e raised to the power minus y minus e raised to the power minus 3y by 2 dy. And on integrating it, we'll get our answer as e raised to the power minus y minus e raised to the power minus 3y by 2 upon minus 3 by 2 upon minus 1, with the limits as 0 and infinity and outside 2. If we solve them, then we get something like 2 into, if we put 0 and infinity here, then we'll get 0 and minus 2 by 3, 1 minus 2 by 3. And on solving this, we'll be getting answer 2 into 1 by 3, which is nothing but 2 by 3. And hence our option number C is correct. This is simple integration, and you should know that integration plays a very important role in our statistics paper 1. So you should be thorough with all the concepts, and if you're not, then you should revise all your concepts before going into the examination hall. Then this is another question where joint density function has been given to us, and they say that if we consider this as a joint density function, then what should be the value of x? Again, we'll take integration, double integration. First integration, let us take first integration as y minus x 2x, and second integration of x 0 to 1, because it gives us direct values, so we'll take that. C into x plus y dy dx should be equal to 1. So integration of 0 to 1, c comes outside, and if we integrate x plus y with respect to y, it will be xy plus y square by 2 minus x 2x dx should be equal to 1. And if we integrate it, it will be x square plus x square by 2 minus x square it will be, so it will be plus x square minus x square by 2. These and this can cancel, and we are left with 2x square. So I'm writing it here, c into integration 0 to 1, 2x square dx should be equal to 1. X square on integrating will be x cube by 3, and 2c comes outside, with the limit 0 and 1 should be equal to 1. So if we put the limit 1 and 0, it will be 1 upon 3 only. So we can say it is 2 upon 3c equals to 1, and hence c comes out equal to 3 by 2, which is our option number B here. You can see that. This is a simple integration question, and these questions have been taken from PYQs only. So you can just see how they have asked questions based on these topics, and these are very scoring topics in your examination. Moving forward to the next question. Here they have given us that this is a continuous random variable joint PDF, and we have to find the probability y is less than 1. When they have given us probability, then we should consider this probability while integrating the topic. So integration, double integration will be there. First of all, we'll take the integration x is less than y. So we'll take inside the integration of x. X is less than y means maximum value of x is y, and minimum here you can say it is minus infinity. And here y has the limits as minus infinity to 0. Fxy is e raised to the power x plus e raised to the power y. I can write it as e raised to the power y d. Inside we have taken the limits of x. So first we'll write x, then we'll write dy, and we have to solve this question. I hope you know how to make these statements. As soon as you make the statement, there is nothing but to integrate them. So first of all, we have to integrate x. So we'll take y outside, e raised to the power y, and we'll integrate e raised to the power x. Now e raised to the power has integration e raised to the power x only, with the limits minus infinity and y and dy. Now e raised to the power minus infinity will be 0. This you should know. This is and e raised to the power y is e raised to the power y only. So it will be minus infinity to 0 e raised to the power y into e raised to the power y only. Minus 0 will be 0 only. So instead of writing it twice, I can write it as e raised to the power 2y dy. Now integrating this as well, e raised to the power 2y has integration e raised to the power 2y upon 2 with the limits minus infinity and 0. If we put the limits here, we can take 1 by 2 outside. E raised to the power 2 into 0 will be 0 minus e raised to the power minus infinity, which is equals to 1 upon 2, 1 minus 0, which is 1 upon 2 only. And hence our option number C is the correct answer for this question. Now moving forward, this is the 2019 PYQ of our ISS paper, and see how easy question they have asked in the examination. They have given us uh, joint PDF, and they have asked us marginal distribution of x. Now we have done that marginal distribution of x is nothing but the integration over y with joint PDF xy with respect to dy. So here the limits of y you can see is 0 from 0 to 1. So we can write 0 to 1. Fxy they have given us 4xy dy. Now we have to integrate this with respect to y. So this 4x will be considered as a constant. So we'll take them outside. So it will be 4x integration 0 to 1 y dy. Now this y when integrated will give us y square by 2 with the limits 0 and 1 and 4x. So it will be 1 upon 2 minus 0 upon 2 will be 1 upon 2 only. 4x into 1 upon 2, which will cut it down and give us answer as 2x, which is our option number B. Here you can see it is 4x, 2x, x by 2x. So B is correct with the limits x they have already provided in the question. So this is your correct answer, and it was not even a question of 30 seconds. So that's how, if you know the concept, you'll be able to do the questions within the time limit in the examination hall. So this was all for today's lecture. I hope that I was able to help you in this topic. And if you're still facing any doubts on these questions or the questions that we have done previously, and then you can ask in the comment section. And if you're not facing any doubt, then you should work on your skills to improve your question solving skills. Now you should search for more and more questions and try to solve them on a regular basis. Then only you will be able to do it good in your examination. And give us questions as well, so that we can also help you. We'll be happy to help you. And many of you have been asking questions. That is a good sign that you are preparing well. And many of you aren't still asking any questions. So I would suggest you all to start working now, because there is not much time left. All the best. Thank you.